Can science prove things? This one is big. It's so big that even some scientists actually fall for it. Can you tell me what is a proof? If you're stuttering, I'll help you. A proof is a logical demonstration that the conclusion must be true if the premises are true. It is not based on experiments, probabilities, or evidence. It's based on deduction. In other words, you will never obtain a proof from a scientific experiment. Let's take an example because I can see that you're lost. You can prove that the sum of the angles of a triangle is 180 degrees. The premises here are the axioms of Euclidean geometry. Just think of these as the rules of the game of geometry. So, if you assume these axioms, then the proposition, the sum of the angles of a triangle is 180 degrees, must be true. It just cannot be otherwise by the laws of logic. And if you think that you could just draw a triangle and measure its angle, you're gonna give a heart attack to all your math teachers and also to me. So please don't do that. If you still got lost, here's a non-mathematical example. When I say Socrates is a man, all men are moral, therefore Socrates is moral. This is also a proof. If the premises are true, and they are, then the conclusion must be true, because this is what we call a valid argument. It follows the laws of logic. So it's really important to distinguish between math and logic on one side, which are deductive disciplines, and then all the sciences on the other side, which are inductive disciplines. Let me say it clearly. Science doesn't prove anything. And personally, this is why I was very attracted to math as a kid, because you had this feeling of certainty. You prove one thing, and then that's it. You have done it forever, for you, for me, and for all of humanity. But, as I said, science doesn't work like that. Science doesn't deal in eternal truth. It builds models. You make a hypothesis about the world, you test it with data, and then you see how well it predicts. Take Sir Isaac Newton. He built a model to predict how objects fall. And he came up with a very elegant formula that applies to everything that falls on us, whether it's this pen or the moon. And this formula didn't just come from theoretical assumption. He actually tested it with real data. With his theory, you could, for example, predict the impact of a cannonball. And up to a few exceptions, his predictions were very accurate. Notice that I say accurate and not right. That's important because a proof is right or wrong, but a model is more or less accurate. It's a continuum, and actually, Einstein had a better one than Newton with his theory of general relativity. But even his model suffers in the most extreme cases, so Einstein's model is just better than Newton's one. Neither is right, and neither is wrong. That distinction matters, especially when things get controversial. During COVID, for example, epidemiological models weren't right or wrong. They were more or less accurate, depending on the data, the assumptions, and the timing. So, when some prediction missed, it's not that the scientists were biased or clueless. It just meant that the models needed refinement, as all models do. As with all things, the only absolute error is to think in absolutes. So, that's actually just one type of scientific inquiry. You build a model and test it to see how well it does. But there is another way to deduce scientific facts, and it doesn't involve models. It's just about counting things. That's what I tackle in the full deep dive, links in the description.